application and application areas of nanotechnology. What is nanotechnology? Nanotechnology is about looking at the world on such a tiny scale that we can not only see the atoms that make up everything around us, including ourselves, but we can manipulate and move these atoms around to create new things. Nanotechnology is science, engineering, and technology conducted at the nanoscale, which is about 1 to 100 nanometers. Nanoscience and nanotechnology are the study and the application of extremely small things and can be used across all the other science fields such as chemistry, biology, physics, material science, and engineering. The idea of nano concept behind nanoscience and nanotechnology started with a talk entitled "There is a Plenty of Room at the Bottom" by physicist Richard Feynman at an American Physical Society meeting at the California Institute of Technology on December 29, 1959, long before the term nanotechnology was used. In his talk, Feynman described a process in which scientists would be able to manipulate and control individual atoms and molecules. Over a decade later, in his explorations of ultra-precision machining, Professor Noro Tongic coined the term nanotechnology. It was not until 1981, with the development of the scanning tunneling microscope that could see individual atoms, that modern nanotechnology began. So,
to nearly 2 meters tall on the tall side. Now let's move to the left along the scale bar and consider smaller objects. A mobile phone is about 0.12 meters long, or 12 centimeters long. Continuing on to smaller objects are insects, such as ants. These ants are about 2 millimeters long. So we're now at the millimeter scale, or 1/1000th of a meter. Continuing on to the left on the scale bar are even smaller objects. We have a human hair, for example, as seen under an optical or light microscope. The width of the human hair is 0.1 millimeters or 100 micrometers. In the lingo of the nano world, we call micrometers microns. Now we see bacteria here, such as E. coli, or even smaller. These bacteria have been imaged with an electron microscope, and the bacteria are about 2 microns in length. So an E. coli bacteria are about 1 million times smaller than a human. But hold on, viruses and DNA are much smaller than bacteria. So our next object here is a reconstructed image of a virus. This just isn't any old virus either. This is the rhinovirus, which is the cause of the common cold. The width of a rhinovirus is a mere 30 nanometers. That's 0.03 micrometers, which is nearly 10,000 times smaller than the diameter of a human hair. At the far left side of our scale bar, we have a DNA molecule with its characteristic helical shape. The width of the DNA helix is about 2 nanometers, which is about 1 billion times smaller than the height of a human. So back to our first question, nano, meaning 1 billionth, describes feature sizes that are about 100 nanometers and smaller, which is this left side of the scale bar. Just for fun, let's go in the same as comparing the size of the sun to us. Technology at the nanoscale is a diverse field that's part of our everyday lives, often in ways we don't realize. Nanotechnology is used in many industries.
Nanotechnology, and next fundamental concept in nanoscience and nanotechnology. It is hard to imagine just how small nanotechnology is. 1 nanometer is a billions of meter, or 10 to 9 of meters. Here are a few illustrative examples. There are 25,400,000 nanometers in inch. A sheet of newspaper is about 100,000 nanometers thick. On a comparative scale, if a marble were a nanometer, then 1 meter would be the size of the Earth. Nanoscience and nanotechnology involves the ability to see and control individual atoms and molecules. Everything on Earth is made up of atoms. The food we eat, the clothes we wear, the building and house we live in, and our own bodies. But something as small as an atom is impossible to see with a naked eye. In fact, it is impossible to see with the microscope typically used in high school science classes. The microscope needed to see things at the nanoscale were invented relatively recently, about 30 years ago. As small as nanometer is, it is still large compared to atomic scale. An atom has a diameter of about 0.1 nanometers. An atom's nucleus is much smaller than 0.00001 nanometers. Atoms are the building block for all matters in our universe. You and everything around you are made up of atoms. Nature has perfected the science of manufacturing matters molecularly. For instance, our body are assembled in a specific manner from millions of living cells. Cells are nature's nano machine at the atomic. The scale elements are at their most basic level. On the nanoscale, we can potentially put this atom together to make almost anything. In a lecture called Small Wonders, the world of nanoscience, Nobel Prize winner Dr. Horst Dorman said that the nanoscale is more interesting than the atomic scale because the nanoscale is the first point where we can assemble something. It is not until we start putting atoms together that we can make anything useful. People are interested in nanoscale because it is this scale that the property of material can be very different from those at a large scale. We define nanoscience as the study of phenomena and the manipulation of materials at atomic, molecular, and micromolecular scales, where property different significant from those at large scale, and the nanotechnology as design, characterization, production, and application of structure, devices, and the system by controlling shape and size at nanometer scale. The property of material can be different at nanoscale for two main reasons. The first one, nanomaterials have relatively large surface area when compared to the same mass of material produced in a large form. This can make materials more chemically reactive. In some cases, materials that are inert in their large form are reactive when produced in their nanoscale form and affect their strengths or electrical properties. The second, quantum effects can begin to dominate the behavior of matter at the nanoscale, particularly at the lower end, affecting the optical, electrical, and magnetic behavior of material. Materials can be produced that are nanoscale in one dimensions. For example, nanowires, nanorods, nanotubes in 2 dimensions, plate-like shape like nanocoating, nanolayers, and a graphene, or on all 3 dimensions, for example, nanoparticles. Today, scientists and engineers are finding a wide variety way to deliberately make materials at the nanoscale to take advantage of their enhanced properties such as higher strength, lighter weight, increased control of light spectrum, and greater chemical reactivity than their large-scale counterpart. Application of nanotechnology. Application of nanotechnology in medicine. Customized nanoparticles, the size of molecules that can deliver drug directly to disease cells in your body. When it is perfected, this method should greatly reduce the damage treatment, such as chemotherapy, does to a patient's healthy cells. Application of nanotechnology in electronics. Electronics, it has some answer for how we might increase the capabilities of electronic devices while we reduce their weights and power consumptions. Application of nanotechnology in food. It has an impact on several aspects of food science, from how food is grown to how it is packed. Companies are developing nanomaterials that will make a difference not only in the taste of food but also in food safety and the healthy benefit of that food delivery. Application of nanotechnology in agriculture. Nanotechnology can possibly change the whole agricultural part and nourishment industry, anchor from generation to preservation, handling, bundling, transportations, and even waste treatments. Application of nanotechnology in vehicle manufacturers. Much like variation, light and stronger materials will be valuable for making vehicles that are both quicker and more secure. Burning motors will likewise profit from parts that are all the more hard-wearing and higher temperatures safe. This is all what is nanotechnology and the fundamental concepts in nanoscience.